So this little video explains how to solve problem number 55 in chapter 4. This is in Zumdahl and Zumdahl, the Adams' first approach to general chemistry. All right, so what you're asked to do here is to find or estimate the change in energy for the formation of 1 mole of potassium chloride solid from its constituent elements, potassium solid and chlorine gas. And you're given this information: lattice energy of potassium chloride, the first ionization energy of potassium, energy of sublimation of potassium, the bond energy of a chlorine molecule, and the electron affinity of the chlorine atom. So let's look at it. This is a Born-Haber cycle problem, and so I always draw this circle when I'm doing a Born-Haber cycle problem. So the idea is we're starting in the Born-Haber cycle. We start with a solid ionic compound, in this case potassium chloride, and the first step is to break it apart into its constituent elements, that is, in their standard states. So potassium chloride is made of potassium and chlorine. The standard state for potassium is potassium solid, but chlorine, it's a heteronuclear diatomic in a standard state, so it's Cl2, chlorine gas. But we only have 1/2 a molecule here, or a mole. Next step is, once we have everything broken apart, and oh, by the way, notice that this step right here, this is exactly the opposite of what we're trying to find. I'm going to call this step A. So the change in energy we're looking for is negative A. The second step is to sublimate or change anything that's not a solid, not a gas, into a gas. So here, all chlorine's already a gas. We just have to sublimate potassium, go from a solid to a gas. The next step is to create the cation. In this case, it's potassium with a +1 charge, so just this step right here is the first ionization energy for potassium. Next step is to break any bonds. So here we have this chlorine molecule. We have to break the chlorine atoms apart into 1/2 a mole of chlorine gets broken into 1 mole of chlorine atoms. And then we make the anion. We add the electron onto chlorine in this case. Electron affinity for chlorine would be the change in energy for this step, and it's Cl-. Now we bring them back together and end up where we started. This step here is the lattice energy. The change in energy for this step is the lattice energy. Notice that we ended at the same place we started, which means when we add up all the changes in energy, they have to add up to be equal to 0. So I've labeled each of these A, B, C, D, E, and F. A plus B plus C plus D plus E plus F equals 0. What we want for this particular problem is to find negative A. Remember, because it's negative because it's the opposite direction. The direction we're going in this cycle is from the ionic compound to its elements. We want to find the change in energy from the elements forming the solid. Change the sign of the change the direction of the arrow, change the sign of the delta E. So we want negative A, which is just going to be, if we rearrange this a little bit, B plus C plus D plus E plus F. All right, so now all we have to do is write down what they are. So B was the sublimation energy for potassium, which is this. C is the first ionization energy for potassium, which is this. D is 1/2 the bond energy for chlorine, which is 1/2 times 239. E, it's the electron affinity for chlorine, and F is the lattice energy. We add all these guys up, and we get -437 kilojoules per mole. That's the answer.